Hello friends, myself Shriram Korde. So let's see some more examples with respect to usage of loop. An interesting thing is I want to see the ASCII, basically the characters. Okay, now if I want to see the ASCII characters, then it's very easy that way to do that. Okay, so let us say how do I do that. Now I will write it here. So I want to print all the ASCII values. Essentially I want to print all ASCII value. And when I say I want to print ASCII values, I also want to print equivalent characters. That means I want to see what is the ASCII value of A, what is the ASCII value of B, what is the ASCII value of C, like that. Similarly, what is the ASCII value of digits 1, 2, 3, 0, 1, 2, 3, like that. Then what is the ASCII value of small case letters like small a, small b, like that. Then there are special characters. So these things essentially as part of uh, the language, essentially you have it as part of 0 to 255. Now when it comes to wide characters, obviously it will go beyond 255. Okay, right now we are not considering wide characters. Okay, so we will do it not for, I will just write it, not for wide characters. Why? Because when you say wide character, then essentially we are talking about internationalizations, and we can occupy the characters which typically are shown as part of, say, Japanese language or Chinese language and things like that. So right now we are not considering that. We will basically consider typically what comes as part of our Roman letters or the English characters and things like that. Okay, so that is what we will consider. So to do that, essentially it's very easy also, and it's very interesting. So you have basically 0 to 255. Okay, so that is what I told you, 0 to 255. Now that means we are going to start with 0 and we are going to end with 255. So for that I can simply have a variable int character and say, I'll just say c is equal to 0. So I'm going to initialize this to c is equal to 0, and then I can simply write a loop. Okay, so let me just write a loop while c is less than equal to 255. Why? Because I just told you there are characters from 0 to 255 with this ASCII values. This is very important. This is ASCII values. These are values. Now we want to see the equivalent characters. So that is what is very important. Okay, so what is the equivalent characters of that? So to do that, we could have used for loop also, but right now I am using a while loop. So we can simply put printf, and then in printf we can have percentage C and percentage D. Okay, and then we can keep it here, and or it is little tricky to do. There is a chance that we may not be able to see everything. So like right now let me just put here T and let's see how it works. Otherwise we might have to use N. Okay, and then we will simply use C comma C. So now what exactly is happening is this percentage C is going to print the character, whatever the printable character. If it is not printable on the screen, obviously you will not see there. But the important thing is this is the value. So let's see this, and then obviously we will increment it. Okay. So right now I don't want to mess up with all 255. Probably, okay. So we'll play with this a little later, and we will ensure that we basically are able to see to a certain extent properly. Okay, and then we have written 0. So let's see this working. So we want to print this. It's very easy but very interesting. Yeah, so now you can see that completely it has come. However, we have to really do a scrolling. Okay, so this is the code that we have written, and C, that means we started with from C is equal to 0 we and ended at 255, and now this table or this sort of two things together is going to print. So we started with 0. Now you will see ASCII value of ASCII, that means 0 is a character now. ASCII value is different. Okay, that is what is interesting. Okay, so let's concentrate on something which we are probably used to it. Okay, So let's see this small b here. So you will see this small a starts from 97. This is the small a. Then this is small b. So small a ASCII value is 97. Small b's ASCII value is 98, 99, 100, 101 until say small z is 122. Similarly, if you look at capital or large case capital A, so here you will see this capital A starts with 65. So 65 to Z, that is 90. Okay, so 65 to 90 is where you have characters A to to Z, which are capital characters. Then you can see various other things like star. What is the if character is star, then what is the ASCII value of that? Like that. Okay. Then similarly, you will see plus, then minus, like that. You can keep on seeing all these things essentially will come like this. Okay. And then you will see curly brackets and all that. Okay, so what is the curly bracket? Here you will see this. So like that you will see from 0 to 255, and then you can see for digits also. So somewhere you will find it for digits. So these are all the alpha, beta and all that, and then you can have it for digits. Okay, so that's the way typically you will have A, B, C, D, and then these are the digits. We will say this ASCII values. This is 0. Yeah, this is 1, 2. Yeah, you can see this 1, 2, character 1. This is character 0. So that is what many people get confused. So when you say 0, that means its ASCII value is 48. This is very interesting, and I will repeat this later in further videos also as at that appropriate topic. So 0, 48, then 1, 49, 250, like that you will have till 957. So that's the way typically this ASCII table, this is called as ASCII table. So essentially what we did was a ASCII table, and you can find this in any of the standard books, or you can just say Google with ASCII table and you can see this table coming up. Okay, so that's essentially the program that we learned just now. Now we can basically try to solve another problem, and that problem can be, how do I basically convert a decimal number to binary. You can try other things also. Right now I am going to do for decimal to binary. So obviously here I will have to take number. So let's do that. So when I want to do decimal to binary, what essentially we are doing it, we are dividing it by 2, and we basically keep on dividing the remainder. Okay, so that is what we do. And then when you divide it, then obviously the number basically will also get divided by 2. So let me just show you that process, and then I will explain you that. Okay, so we will enter a number, we will have to do that. So we will define the number, and then we will have the number after division, and then the remainder. So R is for remainder. So n is the num is the original number, that is the entered number. I will say entered number. Then n is the number which we use during working. So that is during algorithm or during working of the code, and that is for n, and then R is the remainder. Okay, R is the remainder. So we can now basically just, and then obviously we will have a binary number. So I want to have final answer, so I will have it decided as long. Why? Because the number can be larger one. Because if I enter say 1058 is the input number, then obviously the equivalent binary will be pretty large. So at least we should be able to take care of that, and that's why I am using a long data type here, and I will initialize this long data type to be 0. So this is where we are going to have the answer, which is binary answer. This is binary number. Okay, binary number. Now we require a loop, so obviously we will have int I is equal to 0. We will initialize this I to be 0. So we will then say printf enter decimal number, enter a decimal number, then we can do scanf, and percentage D and the number. So we will have it here, the number. So once you get the number, now we simply have to use it. Okay. So I am just using this n as a temporary word. I told you like n is used essentially for the temporary working. So it is used for working. Okay, working calculation. So what I do, I basically initialize this n to number. So that number, whatever the number which user has entered, it will get preserved in case you want to use it later. That means as a part of last printf or something, so we can use it. Okay, so n is number, and now we can simply write a loop. So what do I write in the loop? So let's first write a loop and then we will just see that. So remember, we will first divide the number n mod 2 and the remainder will be in the r, and then because of that we are going to divide the number n is by 2. That means now you divide the number and whatever the remainder you basically have, that is a standard algorithm which you basically use as part of the paper pen calculation. Like you keep on dividing a number by 2 and then the remainder essentially will be kept into the r. Okay, and then you basically have n is equal to n by 2. That means you keep on dividing it by 2. Okay, and then you ensure that whatever the remainder you get, that essentially is your answer. So we will see how do you get that now. So now you have this answer which is in the bin, and then what do you do is you basically are going to add bin. That means whatever the bin, because we initialized it bin to 0, and then bin, and then we are going to do 10 to the power of something. So what is that 10 to the power of something? So here now we need to do something very interesting. So for that I am going to use a power. So here it's going to compute power for me. Okay, and I am using the ready-made things from math.library. So math.h essentially gives me a power function. It gives me several other functions like square root and all that, or square. So like that, here I am going to use a ready-made function which is going to compute power of what? Power of 10 to the power of I. Okay, and that's what you require basically when you do the binary to decimal to binary computation. Okay, so you basically are going to have 10 to the power of I, and then you multiply this by r. That's what I told you. R is the final answer. You simply multiply it by whatever the tens place it has. So that means 10 to the power of 0, 10 to the power of 1, like that. Okay. Now I am not showing you all the paper pen calculation. That you can always get it in any of the books, or you must have studied that in the colleges. Okay. So now, or even in your school days. So power of 10 to the power of I multiplied by r, and then you basically add it to the bin. Okay. So that's it. And then we now have I. So why I didn't use I? So obviously here n, and n, what is now happening here is n is getting divided. That means n is going to become it is going to reduce. So that means now we need to check whether n is not equal to 0. So n not equal to 0. Okay, and then what is remaining is I. So I we have initialized it to 0. So that means 2 to the power of 10 to the power of 0, 10 to the power of 1, and you multiply it with the remainder. So that is what you achieve by doing this. Okay, so I will have I plus plus, and then finally I will printf percentage LD and comma the answer, which is answer is in the binary bin variable. Okay, so let's do that now. So we'll enter a number. So for the time being, let's enter number 5. Yeah, so that is correct, 101. Now let's enter another number. Say 4. So 100, that is correct. Why? Because 4 is 100, 5 is 101, like that. Now if I enter a little bigger number so that we understand it, so let me enter 15. So it is all 1. Okay, so that's the way. And then if I enter 16, obviously 1 will shift there and all remaining will be 0. So that's the way typically you work on decimal to binary conversion. So similarly you can do decimal to octal. Now if you want to do decimal to octal, you can very easily do this. instead of 2 you simply use 8. Okay, so if you do 8 your job is done. Okay, remaining is because now you want to do from what you call it as decimal to octal. Okay, so because of that if you simply use essentially 8 you can solve this problem. You can work on this obviously a little bit more, but it can be tackled. Okay, so that's a very interesting thing. Here it will remain the same, the n mod this one, so instead of 2 it will be 8, this can be 8, and then you can remaining remains the same, power 10 to the power of I, and all that thing will remain the same, so you can always do that. Okay, so I hope you like these two problems which we considered in this video. So one was obviously we took ASCII table and it's a very interesting thing, and we should know this, and we did it from 0 to 255. And another is another code where you essentially handle decimal to binary, and on the same logic you can do decimal to octal also. So you can do decimal to octal also using the decimal to octal also you can do on the similar lines. I hope you like these videos.